Okay, so we're going to continue our work on gravitational forces and gravitational energy. So let's go ahead and look at this problem right here and think about a strategy that we can use to solve. So first thing I'm going to do is I'm going to draw a little picture. So we have a rocket on the surface of the Earth. So here's our rocket, and it's launched upwards at what? Velocity is 3.1 kilometers per second. We have the radius of the Earth at some distance from that. And then we want to know how high above the surface of the Earth does it reach? So it starts at that point and then it goes to some point higher. And we're trying to find this height right here. And this is our rocket right there. Cool. And again, that is the radius of the Earth. Cool. So I went ahead and drew a picture. Looking at this picture, let's think about what kind of setup does this look like? You know what? This looks just like an energy conservation setup. Anytime we're changing velocities and we want to find a height or a velocity, and we're changing heights, energy conservation is going to be a great bet. So let's go ahead and look at our two pictures. So we know when it reaches its highest point, we know the velocity is 0 meters per second. So let's go ahead and label that. So let's go ahead and, again, we have these 2 points. This point here in yellow and that point there in yellow. Let's go ahead and label what type of energy it has at each point. So take a guess yourself and then let's check back together. Cool. So here we have some sort of KE because it's moving. Okay, this is tricky too. So now, since we're dealing with planetary motion, which we talked about in a previous example, we can't use the equation UG equals MGH because now we're measuring our reference point from the center of the Earth because this rocket or whatever it is traveling such big distances where the acceleration due to gravity changes. So again, we're using this equation, which measures from center to center. So there is, at this first position right here, there is some gravitational potential energy. The rocket is some distance from the center of the Earth. Cool. So now let's go ahead and look at our other point. So when we get up here, velocity is 0, so there is no kinetic energy. There is some gravitational potential energy because it is some distance from the center of the Earth. And again, that distance is just going to be RE plus H. Cool. So now let's go ahead, take a guess how to set up this conservation of energy equation, and then let's check back together. Cool. So we have UG, and I should use a big G because that's what we're dealing with. UG plus KE equals UG. No KE at the highest point. So we have negative G, what? Massive rocket, massive Earth, over radius of the Earth. So at the first position, that's the distance from the rocket to the center of the Earth, plus 1/2, what? Massive rocket times velocity squared equals what? Negative G, massive rocket, massive Earth, divided by the total distance, which is the distance from the rocket to the center of the Earth, which is going to be RE plus H. Cool. So let's see if we can simplify anything now. We know there's an MR in every single term, so that can just simplify out. Gosh, I love it when things simplify. And let's go ahead and plug in numbers too for our next step. So we have negative what? 6.67, 10 to the negative 11. Mass of the Earth, I know from my handy dandy table, that's 5.97 times 10 to the 24th. Radius of Earth is 6.38 times 10 to the 6th, plus what? 1/2. Velocity is 3.1 kilometers per second. We need that in meters per second, and that's going to be 3100 squared equals negative 6.67, 10 to the negative 11, 5.97, 10 to the 24th, over radius of the Earth at 6.38 times 10 to the 6th, plus this is the height we want to find. Cool. So now we go through a lot of math, and then we can get the H. I'll just put a couple of the steps on, but I encourage you to go through it yourself. So this full left-hand side, I get. Cool. So that's what I get when I simplify all that. And again, that's the whole left-hand side and the top of the right. Now I can, let's see, move some other things around. So I can multiply both sides by 6.38 times 10 to the 6 plus H to get that to simplify, and then divide both sides by, oops, sorry, I forgot a negative right there. Added that negative. And then divide both sides by negative 5.766 8636. Cool. Cool. So I went ahead and did the last little steps, and I got the height to be 5.32 times 10 to the 5th meters. Awesome. Thank you so much for watching.